What do I have to say? So in this video, you're going to learn how to use Firebase in Nuxt the right way. And we are going to build this beautiful demo app, which is full stack. So it's connected to our backend. And we are going to see different features of Firebase, such as authentication, also with different providers. We are going to look into Firestore, how to read, edit, and synchronize data using snapshots. So no yapping, let's go. So I'm here in a fresh new project that I created starting from my template that you find in the description. And if we go on the server, we do not have anything. I just cleared it a little bit, so we have a blank page. And the first thing we want to do is just install the required dependency. And we are going to install Firebase to handle the connection to Firebase. Then we are also going to install the Firebase Admin because we are going to use admin SDK on the server. And finally, we are going to use Pinia. For those who don't know, it's just a state management library for Vue and Nuxt. So we can just install the dependency. We can go into our terminal and just run ban install or whatever package manager you're using, Firebase and Firebase Admin. We can let it install. Okay, once it is installed, we need to install Pinia, and we can install this using the module notation. So if you go to the documentation here, you click on get started, you see here you have Nuxt on the left, and then you have this simple command to install Pinia. So you can copy this, go back here. Instead of npx, I'm gonna use banx and then let it install. Okay, so Pinia is installed, and we can check that the installation was successful by going to our Nuxt config and check that we have our module here, right here. Perfect, so the installation is completed. And now before anything else, we will go to the Firebase console and create our project right away. So we can go to our Firebase console here, and we can click on create a new Firebase project here. It's going to ask for a name. We can put, I don't know, Nuxt Firebase. We can leave the default ID like this. We can click continue. It's gonna ask us some configuration. We do not need Gemini for now. We can click on continue. We do not need analytics. And then we can click on create project. Okay, so the project is ready. We can click and access our project right here. And on the left, you have all the different functionalities that you can enable. And the first thing we want to do is just go to the settings right here, project settings. And we want to go to the service account tabs because as we said, we are going to use Firebase Admin SDK on the server, and we need a service account to authenticate our admin SDK. And now once it loads, we can see here that we are on the Firebase Admin SDK panel, and it's going to tell us how to initialize, but we're going to see later. And then we can click on generate a new private key right here. It's going to tell us that it's going to be very sensitive, and then we can generate the key. And the key here is going to be downloaded right here. So we have this key. We can just for now take this and put it in our project. For the moment, just at the root, because we are going to basically copy this inside our env file. And by the way, by the end of this video, I'm going to delete the Firebase project. So this key is going to be completely useless. We can go back on our console here. And once we have the SDK, what we want to do is also initialize our web application. So we can go to our general tab right here, scroll down, and you see here we have all the different platforms for which we can create the project. You can have, of course, a single data source and then access this data from different platforms. In this case, we want to create a web app, so we can click here. It's going to ask us for some information. We can just call it web. We do not need Firebase hosting for now, and then we can click on register app. It's gonna tell us how to install Firebase, but we just did. And then it's gonna give us some configuration, but we can click on continue to console because we are going to have this configuration available right here. Perfect, so we now have also the web application. And finally, since we are here, we can initialize our authentication and Firestore module. So we can go on the left here, click on authentication, and then we can click on get started. In this tutorial, we're going to use two providers because each one of them has a slightly different implementation. But for this tutorial, we are going to use the normal email and password provider. So we can just enable it and click on save. Click here on add new provider. We are going to add also the Google one. So we can click enable. we can just leave the default ID if you want. This one is the name of the project that the users are going to see in the pop-up window. So if you want, you can customize it, but for the tutorial, I'm just going to leave it as the default. And then you have to set the email and then click save. And now our providers are both configured, so we are good to go. And then we can go again inside the build section here, go inside the Firestore database, which is the database that we are going to use. And we can also initialize this one right here. So we can click on create database, and then we can just choose the standard edition, click next, leave the default database, and then I'm going to place this in the Europe. Just be sure that you change it to a location that you're interested in, because as it said here, you cannot change it later. So click next. And then we are going to start for now in test mode, meaning that our rules are going to allow read and write from anybody up to the 9th of February. So this is just test mode, so we can actually test the database. And then we can click on create. We are going to customize these rules later. And now our database is set up, so we are ready. To see up here, you can go to the rules and you can actually edit the rules directly inside Firebase. And then you also have different panels, for example, the usage, the indexes, which allows you to perform aggregated query, since Firebase is NoSQL, so you have to define some indexes if you want to perform advanced queries, but that's probably a topic for another video. And now that we have our Firebase project created, what we want to do is just hook the variables. Specifically, if we go to the project settings here, we want to hook these variables here to our M file and Nuxt configuration, and also the Firebase JSON that we downloaded. So to do that, we can go back to our project here, nuxtconfig.ts, and we are adding our variables to our runtime config. And inside our config, we are going to have first the service account like this, and we are going to take all the variables from our M file that we are going to define later. And then we are also going to have the public part of the runtime config, which is exactly all the variables that we can see here in the Firebase console. So like this, we can just hit save, and now we have the variables binded here in the runtime config. Since we are in the Nuxt config, I want to add a new configuration. So I want to add an app config also, that we are going to use to set the option of whether we want to connect to the emulators or not. So inside here, we can just have a new entry called Firebase. And inside here, we are going to have an emulators entry. For now, we are going to set it to false, but we are going to be able to set it, for example, as this, in which we are, for example, in this case, connecting only to the auth emulator, but not on the Firestore emulator. You can connect to different emulators selectively, but for now we can just put false because we want to connect to the production app. And so we can hit save, and we are done with the Nuxt config. Now, what we need to do is create our M file. So we can just go on the root, create a new file called .env. So inside our env here, we can paste this code right here. And if you see, these variables are exactly the same that we used here in the configuration. So we just need to populate this from our console. So we can just jump back and forth from our console here. I added all of them, and now we need the last one, which is the service account. And now you can link the service account in different methods. For example, you can use just a private key, or maybe just use the whole JSON file. But I've seen that a very, let's say, a good method to do that is just simply take this variable called Nuxt Firebase service account, put it here, and then basically set the whole object inside here. So you can take here the JSON that we just downloaded. So it's this whole thing. Then you can just Ctrl-A and copy all of it and basically paste it here. You just adjust these single quotes right here. And now like this, you're going to have this Firebase service account having the whole object. And I've been using this method for quite a while. It works correctly because in every deployment cloud service, for example, Versa, you can just copy and paste the whole object and it perfectly works. And now we are missing one last part to configure our Firebase, and that is running Firebase login and Firebase init in our project. And to run these commands, you need to install the Firebase tool. So if you go here in Google and search for Firebase tools, you see that you have this npm package. You can also go here to the CLI reference. and it's going to tell you how to install the CLI. And it's basically just installing Firebase tool globally with npm. So you can just, for example, run this command to have it available. I, of course, already installed, so I can go back to my code. And the commands you want to run is just first Firebase login. And of course, I'm already logged in as my account. And then you can just launch Firebase init, and it's going to initialize a Firebase project, hit enter. And it's going to start our guided initialization. So it's going to tell us which services we want to add, and we want to add for now just Firestore and also the emulators, of course, and the authentication, which is enabled by default, I guess. Okay, so we can just hit enter. We want to use an existing project because we already created one. And we want to use this Nuxt Firebase right here. The default file folder rules is fine. Also the indexes. And now it's going to ask us which emulators we want to enable. We want to enable the authentication, the Firestore, and that's it for now. The port is fine. We want also to enable emulator UI because it's very cool. Let's download the emulators. Perfect. Now our project is initialized, and if we go on the left, we can see that we have a lot of new files. But the most important one is going to be this firebase.json, which has information about our project and specifically the ports for our emulators. And we are going to use these ports to configure the conditional connection to our emulators in our plugins. And now, since we have also included the service account here in our env, we can also take this JSON file right here and just delete it. So the first plugin we want to create is the one for our client. To do that, we can go into our app folder here and create a new folder called plugins. And inside here, create a new plugin called firebase.client, hit enter, and now we have our plugin created right here. We are also going to use a slightly different notation for our plugin. Just open this and use the setup function, and then we are good to go, because now with this notation we are able to define some properties. So for example, this enforce property, and we are going to run this plugin as pre, so it's going to run before others. And inside here we are ready to code our connection to Firebase. So the first thing we want to do is just have a reference to our configuration. And if we go here, I'm just taking the app configuration that we're going to need it later for the emulators connection. And then we are creating our app config from our runtime config. And if you do not see here auto-completion, it's because probably we need to run ban install. And now it has catch up, so we have auto-completion. Then once we are here, we want to initialize our app. So we can just do const app initialize app. I don't know why it's not working the auto-completion, so we can, I don't know why, but we can import it. It's just going to be this import right here from Firebase. And we are going to initialize the app passing the client app config that we just created up here. Then we want to get a reference to our services. So the first one is going to be out, and it's going to be get out. Again, I don't know why it's not working the auto import, but we can just import all the stuff right away. So we are importing get out and get Firestore, and also the connection to emulator. So we have our authentication service. Then we can also get a reference to our Firestore. It's going to be initialize Firestore right here. Going to pass the app. And then we are going to pass some custom properties, which is going to be this ignore undefined properties and set it to true. And what this does is basically, since we are on web development, we are usually dealing with undefined properties, and since Firestore cannot handle undefined properties, it's going to throw an error if we attempt to write, for example, an undefined variable on Firestore. And instead, with these properties, just going to basically ignore and set them to null. And now we need to code the logic of our connection to the emulators. So first, we need to get our connection configuration, which is this one right here, and we can create this interface. I have on the template a shared file where we can put all of our types. So if you hit Ctrl P, we can go to, I think it's, yes, share type index. We have this file right here. And so we can just create this interface, which is going to be very simple. And it's going to define whether we want to connect to the emulators of Authentication or Firestore. We can go back here. We can import this. And now we have our configuration, which is taken from our appconfig Firebase emulators, which is the one that we created earlier. So we can have this check right here. If we are not in production, we can attempt to connect to the emulators, otherwise just always connect to the production app, which is exactly what we want. And then we run this logic right here to connect to our emulators. And basically we are checking if we want to connect to our auth emulator or to our Firestore emulator, and then simply call the two functions to connect to the emulators. And we are using this Firebase JSON that we need to import, and it's going to be this one right here. We are importing the JSON file, so basically this one, and we are taking these ports so that if we change them here, it's going to also change them in our connection to the emulators right here. And so this is important that when you deploy the application, you remember to include this firebase.json in the final build. Otherwise, this is not going to be available. And then we can simply log our status and return our two services right here. So basically, by returning this provide in our plugin, we will have available globally these two services already initialized by our plugin. And so like this, we have our plugin on the client side working. So we can hit save and we can go and create our code on the server. So to do that, we can go on the server folder right here. We can create a new subfolder, probably called src. And inside here, we are going to create a new file called firebaseadmin.ts. And we could create also a plugin, but actually, since we are using the Firebase Admin SDK, we are using the standard notation of initializing stuff and exporting from a file, which is more, let's say, in line with the Firebase Admin SDK. First thing we want to do is just import the required stuff from Firebase Admin. You can see here we are using Firebase Admin instead of Firebase right now. And then we are also again taking the runtime config, the app config, and then we are creating the service account, which is going to take the service account entry from our configuration and then stringifying it and then parse it back again to a service account. In this way, we are always sure that whether this is an object or a string, it's going to be correctly formatted. Then we are going to run basically the same logic, but on the server side for our emulators. And the connection to the emulators on the server side is slightly different. You see here that to connect to the emulators, instead of just calling the function, because we do not have them available on the server side, we are just setting an env variable, which is going to be the auth emulator and the Firestore emulator host. And like this, the server node environment knows that it needs to connect to the emulators. Then we are logging again the status. And then finally, we are creating our admin app like this. And then we are also creating our Firestore instance, setting the same property that we did on the client, creating our auth instance, and then exporting both auth and Firestore and also the admin app. In this way, we have them available globally in our server folder. Now we can check that everything is correctly connected and working. Just run the server, go to our page here. And if we reload the page and look here at logs, we can see that we have our Firebase initialized on the client. You can see here. So on the client, it works. But if we go on our logs, we do not see any log from our server. And this is, of course, because this code is not running, because it's not imported anywhere. So just to test it for now that everything is working, we can go on our server folder right here, create the plugins folder. And we can create a new test plugin called indeed test. And inside our plugin, we can just console.log. We can hit save and run the server again. And we are going to see our credentials printed here on the console if everything is set up correctly. And we are going to see basically these service accounts right here. And we can see here that we have all of us service account, and we also have a log of our connection. So everything is set up. We can just go here and delete this test plugin because we do not need it anymore. Okay, stop the server. And now we are ready to start coding our logic. The next thing we are going to do is coding our user composable. So basically we are going to use a Pinia store to wrap all the functionalities and data that we need for our users. In this way, we have it embedded in a single place. And to start this, we can just go to our app folder and create the new composable folder. And inside here, we can create a new folder again called stores. And inside here, we can create our new store here. We can call this user. We're going to change a little bit the notation because I do not like this. We are going to use this notation instead. So we are going to pass the ID, and then inside here we have a function which is defining our store. We want to define some variable. Actually, we want to rename this to use user. And then we want to define some variables, specifically this one. We are going to get a reference to our auth and Firestore, and then we are going to have the data of our user, which is going to be the data of the document connected to our users, because we are going to have a document in Firestore for each user in our authentication. Then we have a boolean to know whether we are logged or not, and then we also are going to have this unsubscribe. We can import this unsubscribe function that is going to basically listen to changes to our user document. In this way, if the document changes for whatever reason, this user data variable right here is going to be synchronized. And of course, we need to define this user data, which is effectively the model of your user. You can go again inside the index shared types, or you can put this wherever you want. And I'm going to have this user data as this, and that's it for now. You can always go here and add new entries to your user data model, so we can just import this. So first method we want to define is this subscribe function. And we can import this on snapshot and also this document from Firestore. And we need to define this function right here, which is going to be this one right here. Again, import everything from Firestore. So what we are doing here is whenever we subscribe, we are telling the authentication package to listen to auth state changed. And whenever we are logged in, meaning that this user is not null, we are subscribing to changes to this document right here. And if you see, it's going to be on the user's ID. So it's going to be the user's collection and the ID of our logged in user. And we are going to listen to these changes. And inside here, the delegate function, we are just going to take the data and synchronize our user value data to the one we just received. In this way, this variable right here is going to be updated and synchronized globally. Then if we are logged in, we are just going to set our boolean variable. And then if we instead are logged out, we are going to set the value to false and our data to undefined. Then we are going to have two methods. One is going to be register and one is going to be login. So this one we are going to use whenever we want to create a new account with email and password, while we are going to use this one when we want to log in with email and password. In this case, I just have my full name, but you can customize this, of course, however you want. And we can import this, and we can define this patch method. It's just a utility function inside here, our user, that is going to basically update and merge the data of our user. And it's going to be a very, very simple function because it's just going to be this one right here. We can import the set doc, and what we are doing is just taking a partial of the user data. If we are not logged in, just return. Otherwise, we attempt to set the document of our users. You can see here users out current user.uid, so the one currently logged in, and we are importantly setting this merge to true. So in Firestore you can use the update doc, but it's slightly different from the set doc because the set doc with merge to true is effectively an upsert, which is kind of what we want in this situation, while instead the update doc, which is this one, is going to throw error if the document is not present. So in this way we ensure that always we are updating the document. I suggest you to check the documentation because I mean the behavior is slightly different, and also it is very important that when you use setDoc you set the merge to true, otherwise the whole document is going to be overridden. So for example, if you have a whole user data saved and you pass here, since this is a partial, you pass here just a data with, I don't know, the full name, and you do not set merge to true, you're going to have your document set to just the full name. So you really do not want that. So remember to always set merge to true if you're using setDoc as an upsert. We need one function, which is this remember auth, which is going to handle whether we want to be remembered in our browser or not. And again, it's going to be super simple because it's just going to be this one. And we just need to import everything that we need. So this too. And what we're doing here is if we want to remember, we are setting the persistence to browser local persistence, meaning that we are going to be stored in our local storage. Otherwise, if we do not want to be stored, we are just setting the persistence to in memory, meaning that we are not basically going to be remembered. And whenever we reload the page, we are going to be logged out, and we will have to perform authentication again. So with this, our users composable is almost complete. Of course, our logout function with which we can exit our account. So we are canceling our subscription to the update of the document, and we are also signing out from our authentication. And once we sign out, this method right here is going to be called with a user of null. And so this logic is going to be run, and we are going to reset our variables so everything is linked correctly. And finally, we need a method that will allow us to authenticate with any different provider rather than email and password. And it's going to be this method right here. So we can import all the different stuff, and then we can explain the code a little bit. So what we are doing here, basically we are passing a provider, which is an auth provider, and you have a lot of different providers as we saw on auth. So it could be a GitHub provider, a Google provider. So this code works for any provider that you want to use. Then you have the remember boolean as always, and then we have this user data delegate, because since we are using as custom provider, we need a way externally to know which data we want to pass. So for example, if you see here, we have this email, password, and data, while instead here we are not passing anything. So we need a way to provide this externally, and we are using a delegate function. We are going to see later how we can use this by passing just the credential, which is the result of our sign-in, and then we are requiring to return our user data. So we are just remembering the auth, signing it with a pop-up using our provider, and then we are taking our user data, we are patching our user data and updating our profile, setting the display name of our auth and the photo URL of our auth. So even if this display name and photo URL, we are not going to use it directly because we are going to use the data from our user data, while instead this update profile is updating this data inside the authentication of Firebase. It's always good practice to just keep them synced. So like this, we are done. We just need to export everything here, the whole stuff like this. Now we can hit save. And now like this, we have our logic for our user completely embedded in this store. Since this is a Pinia store, we are going to have these two variables available globally and synchronized because the state management is going to be handled by Pinia. And now we are ready to start coding some UI. The way we are going to handle this is basically on our pages. Our index is going to become our login page, and we can create a new folder called app, and inside the app create a new index. And basically we are going to treat in this way whatever subroute inside the app as the actual application. So we're going to have also a middleware that is going to guard whether we are logged in or not. And of course you can change the way you are handling this. So for example, if you do not want to have the app in your subroute, you could have the index that is simply just swapping components depending on whether you are logged in or not. But for this tutorial, we are just going to keep it like this. So for now, we have our index, which is going to be our login, and then our index on the app, which is going to be our actual app. One more thing we can do is, you see here, we have this app. So our /app is going to be this index, but in Nuxt, if we define inside the page a new app page like this, so you see here we have an app folder, but also an app view. This app view is effectively going to be used kind of as a layout. And why do we want to do this? Is because we want to guard the access to all of our application without actually defining a new layout. So if we do not have an authenticated user, so basically if we do not have the user data available, so for example, we encountered some error for fetching our data and stuff like that, we want to of course block the access. And to do that, we can make all of our application client only. and we are going to use a uempty, whether if we do not have a user data available, we are just going to display this uempty loading. Otherwise, we are just going to display the Nuxt page, so basically the whole stuff that it's inside here. And we need to import this user, which is our composable like this. This is not a middleware, this is just a whole, let's say, layout that is telling that if we do not have a user data, just wait, otherwise access our application. So for our index, which is our login page, I am going to copy and paste the whole component because I mean, it's kind of useless to see me write everything. So I'm just going to paste everything and then explain all of it. So we can just copy and paste this huge wall of text, and let me explain everything. And we are getting some errors here because probably we forgot to install the right version of Zod. So we can just go here and run ban install Zod. So now the errors are gone. We just need to import this user data from shared types. We can hit save, and now we have everything correctly set up. So let me explain a little bit what this code is doing. So inside our template, nothing very fancy, we are using a Nuxt UI to display some cool login page. So we are using a page card and then some tabs here to display and select whether we want to register, so create a new account, or actually log into a new account. And then we are using this auth form from Nuxt UI. So you can go on the documentation, for example, here, and go to Nuxt UI auth form, which is this one right here. And you can see we have the ability to create this very beautiful auth form right here already implemented. So what I did is just taken this component and hooked into my events. Nothing very fancy, just a little bit of coding. So we can see here that we have one auth form if we are not registering using a certain schema for our login, while instead if we are registering, we are using a different schema, so the register schema, because we are also requiring the name and some different properties. And then when we submit the login auth form, we are going to call this function on sign in submit, while instead, while we submit the register auth form, we are going to call this on register submit. And these methods, what they are doing is the sign in submit is just resetting the error and using the method that we just created using the user store.login, and we are going to log in using all of our data with a try catch. And simply that's it, while otherwise the register submit is just attempting to create a new account using the other method, this register that we just created, passing the whole data, also the full name in this case. And then finally we have this, if we go up, we have this providers entry right here, and if we click on it, we have this enter with Google provider that when clicked, it's going to call this on Google sign in button. Sign in method, sorry. So if we go here, what we are doing is just creating a new Google Auth provider. We are setting some certain scopes that we need for our application. In this case, I'm just setting the email and the profile. So for example, the photo URL and the name. You can of course customize the scope that you need for your application. And then we are calling the function that we developed before. So we are just passing our provider. And then we are also using this user data delegate that we defined. And you can see here that we are returning our user data. And for the full name, we are using the credential user display name. And these credentials are going to be the result of the sign-in pop-up from Google Auth. I know this is kind of difficult, but basically what we are saying is that whenever we successfully logged in with our provider, just get the display name. In this case, for Google, this is going to be the name inside our Google account. And then we also setting the same for the email, the same for the UID of our user, and the photo URL, again, the same of the photo URL of our Google account. And we are returning this user data to this delegate so that our function right here can take this data and patch it, so set it inside our Firestore with this patch method that we developed earlier. So just take the document of the user's collection at the user ID of the current logged in user, and then just set the doc with merge to true. This is just the concatenation of methods call So if we go back to our page, we should have everything set up. And then one last thing we have, if you see here, we are setting, whenever we catch an error, we are setting the error to this auth error to readable. And this is just a simple switch setting, let's say, a string value depending on the error code that we received from authentication. I got these error codes from, of course, the documentation, and we are just mapping them to, let's say, readable strings so the users know what went wrong. I'm not going to focus too much inside the UI part, because what I'm doing is literally simply using Nuxt UI library to handle this auth form. So you can see here I'm specifying the different fields using the auth form field. So you can check the documentation. I'm going to link all the documentation in the description for Firebase, for Nuxt UI, whatever. And also you're going to have this repository available in my GitHub, so you can check the code whenever you want. So now if we hit save and run the server again, we have this beautiful authentication wall. So you see here on the right, the Firebase has been initialized and everything is working, and we can switch between logging in and registering. And you see the providers here is this enter with Google. So right now what happens whenever we log in, you can see here that we have this code inside the index, so the login page, that whenever the user is logged, we are going to just navigate to our app for now, and we are also checking this immediate to true. So whenever we navigate to this page but we are logged, we are going to go redirected to this /app route. So we can actually attempt to create a new account and see what happens. Inside our Firebase here, go to our authentication to see our users. So we do not have any users. Let's go here and attempt to register using email and password. So I'm just gonna put my name. I'm not going to tick remember me, and then hit create account. Let's see what happens. Okay, we can see on the right that we have this user data patched. So meaning that this our data was set to our Firestore. We can go to our authentication here and reload. We can see that we have our account right here. And if we go to our Firestore, we should have our users, ID, and all of our data correctly set up here. But we see something, so we didn't navigate to the app page. And this is simply because if we go to the code right here, we have this subscribe function, which is going to listen to auth state changed, but we actually never called this subscribe. So if we search globally, we have them only in our user, so we never call this. So to actually call this automatically, we can do something very cool. So we can go inside our app folder and create a new plugin called user.client, and we are going to use the same notation as this one right here, meaning like this. And in this way we can set the enforce parameters to post, because we want this plugin to run after we initialized our Firebase. And inside here, the simple thing that we want to do is just take our user and then just simply call user.subscribe. What this is going to do is just whenever the application has started and the Firebase has already been initialized, it's just going to call the subscribe function, which is going to listen to auth state changed like this. So we can go back to our server, reload, and then here is going to say auth, because before we didn't tick this remember me, so our persistence was not set. We can also make a little try here, so we can attempt to register using the same email as before. So we can put the same name and the same email. And if we attempt to create an account, it's going to give us an error saying that the email is already in use, which is exactly what we want. So at this point, we can attempt to log in. So we can go here, set the email, then we can untick this remember me again for now, and just click login. And now you can see that on the right, we have this new user data snapshot because we logged in, and so we just fetched the user data. And we are inside our app, which is empty for now, but is exactly what we wanted. And now if we reload the page, we are inside our application. And the thing is loading because we have this logic right here on the pages saying that if we do not have the user data, we are just waiting to fetch it. This is, correct, but what we want to do is whenever we attempt to access any sub-route of the app, and while we are not logged, we want to be redirected to a login page. And to do that, we can just go here to our app folder and create a new folder called middleware. And inside our middleware, we want to create a new middleware called auth. We want to run this only on the client and globally for all the routes. So you can use this notation auth.client.global.yes. What we want to do inside here is very simple. It's just this. We can import this. So we are just taking our users, and if we are on the index page, which for us is just the login page, and we are logged, we are going to be redirected to app. While instead, if we are attempting to access any route that is starting from our app, meaning that we are trying to access our protected app section and we are not logged, we are going to be redirected to our login page. So this is what we want. So we can just hit save, go back to our page, and you can see that right away we were redirected to our login page. So right now, if we load, we are not logged in because we have out here this console log that's saying that we are not logged in. So if I attempt to go to /app and hit enter, we are going to be right away redirected to our login page. Now let's try the persistence. So we can go on the login, attempt a login, keep this remember me ticked for now. So we can just click login. We entered the app correctly. You can see here on the right, we have all the logs. And then if we reload the page, let's see what happens. We are in the login page, but we are redirected right away inside our application. And this is because we set the persistence. And if you want to know where this is stored, you can go here on top. You can go to application. You have this index DB. You should have this Firebase local storage DB. And inside here, you have Firebase local storage with all the authentication sessions. We are ready to start coding actually our application inside here. So we are going to have a card with some data, log out and stuff like that. So to do that, let's open our index of our app. Let me paste this code right here. Again, this is just UI stuff. We can import our user composable right here. We can hit save and have this logout function created, which is simply going to call our user.logout and then navigate to our index page. So let's see what other errors. We have this unsubmit. So we want to have this unsubmit function, patch our user data with the updated data, and then we can import this use toast. Okay, so this code right here that I just pasted, what it's doing is it's very simple. It's just having a single card in which we are displaying some data of our users. So specifically, we are using a user component from Nuxt UI to display the full name and also the photo URL if we have any. And then we have a uform component that we are using to edit our user data. In this case, we just have the full name which can be edited. So we just have this uform field. And then we have this form schema, just a ZOT validation schema with our full name. And this form, whenever we are submitting, clicking this save button, we are hooking into the submit event of our uform. And what we are doing here is just taking the data of our submit event and patching it to our user using this patch method. This is always the same that we implemented. So we are just patching this data here and then displaying some toast using this use toast composable again from Nuxt UI. And basically that's it. This is what we have. And if we hit save and go back to our page, let it reload, we can see here that we have our new page and everything is working. So we have our here our users, our full name. We do not have a photo URL because we logged in with email and password. And then we also have this full name input field, which we can use to modify the data. We have this logout button, and then we have also this save button that we can use to save the data. So we can test the functionality right away. First thing I want to do is just go here and change my name. So I'm just gonna put, I don't know, Rossi, and click on save. It's going to tell me that the data was saved. And here on the right, we also have the data patched log. If we go on our Firestore, we can see here that my name was changed on the Firestore, sorry. So this is working. And a very cool thing that I want to show is that how listeners are working. So if you go on our composable here, you can see that we used this snapshot subscription. So whenever we are logging in, you see here we are logged in with a user, we are subscribing to all the snapshot of this document, users user.uid. And this means that if we change the data of the document anywhere else, even in the Firebase console, this function is going to be called, and we are going to get our new data updated and synchronized with our local one. We can test this. So we can, for example, go here inside our application. We can see here that the name is Matteo Rossi. But if I go on the Firestore and change it here back to what was it before, so my actual name, we can hit update. Here we can see that is updated. And if we go back to our application, very cool, this is updated live. So it is reflected here, but also here, of course, because it's the same data. And so you have these listener subscriptions available, and you can use this logic for whatever collection you want. So you have, for example, different collection, different documents. If you subscribe, you're going to have the data always synchronized. Just remember that when you subscribe, that means that you are going to read new data every time data is changed, and this can impact the number of reads you have on your Firestore database. But this is something more advanced, so probably a topic again for another video. Now we can also test this logout functionality. So let me just clear here the logs and click logout. We are going to log out and be redirected to our home page. We are indeed being logging out here. If we reload the page, we are going to be logged out, which is exactly what we want. And one last test we can do before implementing advanced functionality is we can test the login with Google. We can go either in login or register, doesn't really matter, because when you enter with Google, you are basically just you're not differentiating between logging in and registering. So I'm just gonna click enter with Google. It's going to open this pop-up, and we can select an account, and I'm going to select the same account that we use to log in with email and password. Firebase is going to link the two accounts and basically convert the email and password account to the Google one. So if we click here, it's going to ask us for some permissions. We can click on continue. And then we are logged in inside our application. You can see very cool that our photo URL now is available. Indeed, if we go to our Firebase, we have here the photo URL of my Google that was automatically filled. And why is that? Because if we go to our users composable here inside authenticate with provider, you can see that whenever we are signing it with the pop-up, we are using this user data delegate, and then we are patching our user data. And if we go to our login page inside the Google sign-in, we can see that this user data delegate is effectively setting the photo URL as the credential user photo URL. And these credentials are the Google credentials coming from the Google Auth provider. This means that this photo URL is going to be automatically populated by the Auth provider and set to the photo URL of our Google account. So this is all automatic and very cool. And now if we go back to our application, log out, and if we attempt to log in again using the same email, it's going to give us an error. You can see here, it's going to tell us invalid credentials. And this is because this account now has been converted to a Google one. So you have to access it using Google. And indeed, if you go to the authentication here, you can see now that the provider has been switched to Google to the same email that I had before. So this is a feature of Firebase, but something that you need to keep in mind. Now we can customize also the model of our users. So for example, here on our application, we just, we can log in. Okay, inside our application, we just have this single field here, but what if we want to have different data? And I'm going to show you how you can change your user model with this, let's say, system. So we can go into our application and go into our index share types, or the place where you store this user data. And let us simulate adding a new field. So for example, in this case, I want to add a new field called role, which is optional and it's a string. And it's going to simulate the role of our user. So for example, if we are working in development, management, or marketing, whatever kind of stuff that is. So we have this new role right here, and this is optional, so it's not going to give any error inside our application. We can go here and basically have a uSelect to select our role. So we can just have this other uForm field right here, which is going to be the role from field. I'm going to have some custom roles here, and then it's going to be modeled to our user data role. So we have this uSelect for our role, and we need to remember to add this role to our form schema. So if we go here, we have full name, and then we also want to have our role, which is going to be add string of optional. Okay, so we can hit save. And if we go here, we are going to have the full name and the role. Perfect. And now if we go back to our application, we can see that we have this role field. We can select something, I don't know, for example, developer, and then hit save. Our data is going to be saved. And if we go back to our Firestore, we can see now that we have this role right here added to our document. And again, it is set as developer, but if we change it, for example, to marketing and hit save, update, we are going to see these changes reflected perfectly on our application. This is very cool, and it has been automatically set to marketing because we are subscribed to changes to our user data. And this new field that we added to our model right here, if you want, you can of course initialize this during registration. So if you want to, for example, initialize this, you can go to your user, and whenever you are authenticating with the provider or registering a new account, you can here, whenever you patch, you can set your custom data and initialize your data so that you have it available whenever your user logs in or sign ups for the first time. So now we are ready to start coding the logic for our nodes. So we are going to have inside our users here, each user is going to have a sub collection, you can see here, called nodes, in which inside we are going to store all of the documents, all of the nodes in different documents. And then we are going to protect this collection using the Firestore rules. So to begin with, we want to create some kind of UI. And again, this is not a tutorial about Nuxt UI and UI in general. So I'm just going to go a little bit fast on the UI thing. And then instead we are going to focus more on the Firestore and the backend functionality. So we can go inside our app page, and we have below this U card, we can add some stuff. So I added a lot of code here. Let me explain. So what we have, start from the HTML, we just have a little controls on the top, so we can use to add new nodes and to refresh the data. Then we have some conditional rendering, whether we are loading new nodes or if we do not have any nodes. And then we have a v4 on cards displaying the different nodes, and we have a form in which we can hook into the title and the content. And then we finally have some controls for each nodes, whether we want to save the node, modify it, and or delete the node. And then we are using this model element to add the new nodes. So whenever we click on add, you can see up here, we are opening this model, which is a component that we developed in a previous video. You can go check it out. What this model does is simply having a UModel from Nuxt UI, which is going to automatically switch to a bottom sheet whenever we are on small screens. So you can see it as a responsive model, that's it. So whenever we are opening our model, we are just resetting our new node data. And then we have a form in which we set our node data to our title and content. And then finally, when we click add, we are calling this add node. And this is the core functionality that we are going to see. I'm going to go a little bit fast on the UI, as I said, because basically you can organize this however you want. I just did some cards with some styling, but the important thing are these functions right here. So it's add node, delete node, and edit node. So what we are doing here is first, if whenever we add a node, we are going to set its edited at value. And by the way, this node data, I also added this node value model right here below our user data. So we have this very simple node data in which we have a title, a content, and a timestamp at which we last edited or added the node. So whenever we add a new node, I'm going to set this edited at a value, and then I'm going to take the collection. So you can see here, I'm taking the nodes collection of this user, which is coming from the user current user data.ed, and the collection of users. So basically we are going to users, user ID, nodes, and we are taking this collection. Then we are creating a new document like this. You can see that if you call this doc with the collection inside, it's going to automatically create an ID and a document for you. And then we are setting this doc using the new node data.value. And we are not, of course, setting merge to true because we do not want to merge. We are adding a new node, so we just want the document to be set to this value right here. And then we are also refreshing the data. We are going to see where this method is coming from. And then we also close the add model. Then if we are deleting the node instead, we just need the ID of the node. So what we do again is just take the document, again, users, current user ID, nodes, ID of the node. And then we are simply deleting the document and refreshing the data again. Edit node, again, ID of the node, new data. Taking the document, Firestore users, ID, nodes, ID. Also, we are updating the edited at time. And then we are setting the doc, this time with merge true because we are updating and editing the node. Then we are again refreshing the data. And of course, in all of these methods, we are displaying some toasts for the user. And that's basically it. This refresh method, where is it coming from? So this is very important. How do we fetch the data? So inside here, we are using this use async data to fetch all the nodes. And so this async data is returning some stuffs. For example, it's returning the actual data that we remapped to name nodes. Then it's going to return us the status and a function that we can use to refresh and recall this fetch function. We are passing the ID as the current user.id nodes, because basically that's what we are fetching. So passing this ID to usersync data means that if we are going to fetch this data in different pages, we are fetching the same nodes for the same users. We are going to basically have the same result. And then inside this function, what we are doing is just taking all the nodes, and we do this by using the getDocs function from Firestore, calling on the collection. And again, users, ID, nodes. So basically we are asking, take the collection of the nodes of these current users and give me all the documents inside this collection. Then what we are doing is just taking these nodes, the documents returned, and we are mapping it to this with ID. So basically it's just a decorator interface that allows us to define a payload and ID. So in this case, we are mapping this with an ID node data, and we are setting the ID to the document.id, and the payload we are setting to the document data casted as node data. So this whole stuff means that inside these nodes, you can see here, we are going to have a list of node data with ID. And then inside our templates, what we are doing is just iterating over our nodes, and we are displaying some data. So for example, the last edited at formatted. Then we have these forms field mapped to this payload of our node. And then we are hooking into our events here. So whenever we click on save, we are calling the edit node with the end.id and the modified payload. And then once we click on delete, we are calling the delete node, and we just need to pass n.id. So again, a lot of the code is coming is due to the UI, because actually if you go down here, the only important code that you need is just this use async data and these three methods right here, which are fairly short, so nothing very fancy. All this code is just handling the UI. So we can just hit save and go back to our application right here and hit reload. Now we can log in again inside our account. We can see here that we have our new nodes section with our add and refresh function. Buttons. So for example, if we click on add, it's going to open this model in which we can add the title and the content. And this is going to be responsive, as I said. So if we shrink down the page, it's going to become a bottom sheet, which is very cool. And this was explained in a past video, so you can go check it out. If we enlarge the page, it becomes back a model. And then we should also have the functionality added. So we can try adding our first node. So we can go here, add, and let's try with test, and then we can hit add, and our note was correctly added. So you can see here we have our notes, and each note is going to be inside a card in which we have the title that we can modify and the content. We can of course save the modified content or delete the note. And we also have this URL that I created, because basically later we are going to access these notes using server-side rendering and using the Firebase Admin SDK. We are going to create a method to access these notes publicly. So right now let's test this functionality. So if we go back on our Firebase here, you can see that we have our users with the ID, and we have a new collection called notes, which inside we have our only document with the content and the title and the edited at timestamp. So everything is working correctly. We can try to modify the note. So go back to our app and let's change the content to content test, and we can hit save. It's going to tell us data saved. And if we go back to our Firestore, we can see that the content has been correctly changed. And again, if we go here and change the title, so for example, we can change the title to test title instead of test note, we can hit update. We can go to our application. We can see that the title is not changed, because of course we do not have any listeners set up for the notes, because this would mean having a huge amount of reads. But if we click on refresh, we can click on refresh, and now we can go here, we can see that the title has changed correctly. And this is because in the code, whenever we click on refresh, we are again calling this use async data again, and all the responsive stuff inside our application is going to update. Let's test also the delete functionality. So we can go here and hit delete, and now the notes has been deleted. We have this toast right here, and if we go inside our Firestore, we can see that inside the notes collection we do not have any documents, so the note has been correctly deleted. So like this, we already have our insert, delete and edit functionality for our notes. What we want to do now is protect our collections. So if we go on the rules here of Firestore, the rules is the way in which you protect your collections in Firestore. Right now we are basically allowing read and write up to the 9th of February. This is because we initialized the Firestore, in test mode. So we can change these rules, and we can also change this locally in our application. So if we go inside VS Code, we have this file here called firestore.rules, which is exactly the same that we have on Firestore, and we can edit this. And so basically what we want to do is just have some rules for our users collection and also all the sub collection of the users. So instead of this code, what we want to have is this one right here. So what we are saying is that for the users collection, whatever user document, we allow the read to everybody, but we allow the write only if the user is authenticated and is attempting to write on the document specified by its own ID. This means that each user can only write to its own document, and this is exactly what we want. And we are doing the same logic for all the documents inside the sub collections here. This is a very simple set of rules. Usually when you have a production app, your rules can become very complicated and big, but still it's the way to go if you want to have your Firestore protected. Now we can deploy these rules, and to do that we can go inside here and open a new terminal. We can run this command, so we can run Firebase deploy only Firestore rules. With this command we should be able to deploy to our Firestore only the rules. It's going to give us a compilation error, probably because yes, here we are missing an if. I don't know why. So we can run the command again. This is the command you are going to use to deploy stuff to your production. And it says deploy complete. So if we go back to our Firebase here and reload the rules, we are going to see that our rules are updated. We also have this tree right here. We can also test this. So for example, if we set the read to false to both our users and sub-collection of users here. And then we click on publish rules. I already did it because it can take up to 1 to 2 minutes to propagate. Then we go back to our application and reload. We can see that basically we are not able to log in and we are stuck here because here on the right, we are getting an error that we do not have enough permissions to fetch the data. And basically this means that we do not have enough permissions to fetch this document of our user right here. And so we are stuck in the loading state, which is also kind of correct, meaning that if we have an error, nothing is going to explode. We are just going to wait here because we have a problem here. So we can just go to our rules here and revert them back here to true and also to true here. I click on publish. And again, it can take up to a minute. Okay, so we have our application working again. And now the last thing we want to do is just use our Firebase Admin SDK to implement as server-side rendering fetching for our nodes in this case. And this is, we need to use Firebase Admin SDK because if we, for example, go here on the code, and if we use use async data, for example, and we await it, it's not going to run on the server because basically the Firebase plugin here that we defined is just defined on the client, you can see here. So it's not going to be fetched on the server, so you're not going to have the server-side rendering benefits. So basically it's just going to load the application empty and then fetch the data on the client. And we want to have the data server-side ready because in this way we can have better SEO and for different other reasons. So what we are going to do is just create inside the app here, or not really the app because it's protected. So we want to create inside the pages here a new folder called notes. And inside here, we are going to have a new folder called user and then a new page called note. So I think you know this notation in Nuxt, but what this means is that we are going to navigate to a certain path at /notes/user/note in which user and note are going to be variables. So if we go on our application right here and add a new note, we can see here that's the URL I created before. So we are going to navigate to notes, ID of the user and ID of the note. In this way, we are going to be able to fetch the user and also the note data and display it in a public page. So we have this code right here. What we need to do now inside this note.view is creating the logic to fetch the data server side. But before doing that, we need, of course, to create an API endpoint, because if we want this to run on server, we need an API endpoint to actually fetch the data. So we can go inside our server folder, create a new folder called API. And then inside the API, we can create a new API called, I don't know, note.get, in which we have this API to implement. First thing we want to do is just assert the method to be a get method. Then we are also reading the query, because in this case, you see here, I'm inside api.note.get. So we are going to pass the user ID and the note ID as query parameters. But if you want, you can have the same stuff inside here as we did here. So you could have API user between squared brackets and then inside node note between square brackets. In this case, you're going to fetch the note at that URL. But in this case, I just prefer to use query parameters. So we are going to get the user ID from the user query and then a note ID from the query note. Then what we want to do is just take the user document from Firestore. So we can just do const user doc. We can call this Firestore. We can see that we can import this Firestore, and this time is coming from Firebase Admin, the collection users, and the notation is slightly different here. Is not composable, but is chaining calls, so it's just a little bit different because this is the admin SDK. Then we go at the document at that user ID, and this is a reference to our user document. We want to check whether the document exists or not, so we get the document and we check. If it doesn't exist, we are just going to throw an error, users not found 404. Otherwise, we can take both the user data and the note. So why are we doing this? Because inside this API endpoint, we want to return both the user data and the note in a single API call. In this way, we can display some data about the users inside the node public page. And instead of repeating this, actually, we can do this and actually have this const user doc get equals this. Yes, so we are taking the user doc. If it doesn't exist, we are returning user not found. Otherwise, we are fetching the data of our users and also the node data. And we are starting from this user doc. So we are going inside here, you see collections, users, user ID, and then again we are chaining to nodes doc node ID. So this is basically the whole path is going to be users, user ID, nodes, nodes ID, and then we are getting this document right here. And we are checking the same thing we did with our users. So we are simply seeing if the node exists. If it exists, we just return the user and the node data. We can import this. Otherwise, if it doesn't exist, we are just going to create an error. And now we have our API endpoint completed, and this endpoint is going to return, as I said, both the user and the node data. And now we can go back to our node page right here and start coding the fetching logic. And the only code we need inside this page is this one right here. So what we're doing is just using the route to get our parameters as user and node, which are the two right here, users between square bracket and node. So we are going to get effectively the user ID and the node ID. Then we are going to use our useFetch to our API/node and setting the query to our two IDs. And then we are awaiting this server side, so we have it available and we are getting the data and the status. We are also console logging the data so we can see later that is server side ready. And we can also at this point use also some CO meta. So in this case, we are setting the title of the page to our node title, otherwise just to node not found. And like this, we already have this data available in our page. We can also check this. So our server is running. If we hit save and go back to our application right here, we can get this ID right here. We can copy it. We can go to a new page, paste it, and open the developer console. And we are getting this very weird error, probably because, yes, we need to stop and run again the server because we installed, did some stuff. We have our Firebase Admin app being initialized here, so everything is correct. And then we can hit reload here. And we can see here that we have the title correctly set. And on the right, we have this SSR data set to our node and users. This means that this data is going to be SSR ready because it's going to be fetched on the server. And this is because on our code, again, we use this useFetch calling our own API, which is using Firebase Admin SDK to access the data on the server. And an important thing to remember is that Firebase Admin SDK completely bypasses rules. So this is very important to keep in mind because if you are exposing these API endpoints. So for example, this API endpoint, it's open to anybody. If you are exposing these endpoints and you are doing, for example, write operation and stuff like this inside your database in public endpoints, this can be very dangerous because people can call your endpoints and basically exploit your Firebase Admin SDK to bypass Firestore rules. We can check that this endpoint is publicly available for now. So if we go on Postman, and just hit this URL right here with these two query parameters, we can just run it and we can see that we are able to get the data of our node. And in this case, it's not very a problem because we are just reading it. And also if you go to our Firebase Firestore rules, we can see that we allowed read anyway. But in this case, if you wouldn't want to allow read, so for example, if we put here false and hit publish, we can just wait for a minute to propagate. We can see that on the app, if we refresh, we are not able to fetch the nodes because we just set the rules to read false. But if we go here and run this function, we can see that indeed we are able to access the resource. And this is because, as I said, Firebase Admin SDK is completely bypassing your rules. So be careful whenever you use admin SDK inside your public endpoints because you really do not want to expose sensible operations inside these endpoints. And if you really need to do something inside your API endpoints, the way to go is just to secure them using JWT tokens, probably using something like Nuxt auth utils. And this is a topic for my next video. So basically how to secure your API endpoints so that only your authenticated users can actually call them. But be sure to keep in mind this thing when using Firebase Admin SDK. So inside our node page, we have the data correctly fetched, but we want to display something. So again, I'm just going to paste some UI code inside our node page right here. We need to import the JS, hit save. And what this is doing is just, again, based on the status of our use fetch, displaying some loading icon, or if there was an error, we are going to display note not found. Otherwise, we are just going to display a ucard in which we have basically the form set to read only because we do not want everybody to modify this. And then we are also displaying a user using Nuxt UI, displaying the data of the users that we fetched using our useFetch server-side ready function. So if we hit save and go back to our page, we can see here that we have our node. We can see the date of it last edit, and we have the data, and we also our users correctly displayed here. We can test some stuff. So if we go back to our application here, and I don't know, we changed this test node to test node 1 and this lorem ipsum to test content. We can hit save. We can see that the modified data has changed. And if we go back to our node here and reload the page, we can see that the data is perfectly reflected here. So we have the data updated and the data is being fetched server-side. So this is exactly what we wanted. So in this video, we integrated Nuxt with Firebase natively, meaning that we handle the connection and the plugin for our SDKs. And you can find online different packages that basically already gives you binding for Firebase. We also have one called Viewfire. And so I want to cover why we decided to integrate natively. The first reason is that you have update protection. So I've had different situations in which either Nuxt or different packages were updated and others were not. So in this case, I would just have to wait for all the packages to just synchronize to the same version. We do not have this problem because as soon as the Firebase packages SDKs updates, we can just update right away because we integrated them natively. And then also you have to think that when you use a library, you have certain patterns and systems that you need to follow. I mean, those libraries usually forces you to use certain design patterns. And if you want to create, let's say, more advanced models or different systems, you are kind of forced into the design patterns of the library that you are using. Finally, in this case, integrating Firebase was not actually that difficult. I mean, we saw it was kind of easy. We are talking about two plugins, one on the client and one on the server. So in this case, it's not really fundamental to use an external library. And so let me know in the comments if you want that I cover different features of Firebase. In this video, I just covered the free one, so the one that you can use with a Spark plugin without having to upgrade to the paid one. I want to cover a technique called sharding on Firestore, which I have found to be very useful. I'm thinking about some videos about how to build full stack web applications with Jenkit AI and how to deploy it to Firebase Cloud Functions, something that I've been using for my latest SaaS that you find linked in the description. That's all for today's video. Let me know in the comments if you want me to cover something specific about Firebase, and cheers!